Hello everyone, myself Tushar Arora. Today I am explaining my first task that is provided from Sparks Foundation. The task is predict the result when a student study 9.2 hours per day. What will be the result when he or she studying per day on this? So first of all we check the data. Our data is giving in this manner in which we have a two columns hours or scores. So we let's start. First of all we import the libraries. We need a pandas, matplotlib, and seaborn. Then we insert the data from external source. We insert our data, so we explore our data information. It's a data frame in which we have a 25 entries. We have a two columns hours and scores. They are float and integer type. So data distribution in which our 25% to 47 minimum values, maximum values, so all of defining. Now we check distribution of data. This is our plot of hours and this is our plot of uh, scores. There is a no much variance, so there is no need of standard scaling. So now we find the relation between hours and scores. So we using scatter plot. We the plot is showing that the plot is moving in increasing order, in which we can say as the number of hours is increasing, as the result is also increasing. So now our next step is variable and feature selection, in which we have assigning our data as an input or output. Our axis we have a hours going to as an input and the result is score. So now the another phase is now our data splitting the data for train or test. We are working on 80-20 behavior, in which our 80% data is going for training phase and our 20% data is going for testing phase. Now we have a selection. We have a using linear model because both our data is going in a linearly, so this is a perfect suitable for perfect. So now we train the model. We train now our model is trained. Now we have a predicting the result. So first of all we predict the result on our testing data. So we predict the data, we get a 5 predict. Now we have compare between predictions and the actual results. We can say that this is our we have a making a data frame and printing this data frame in which we have a two uh, metadata actual and predicted data. So we have seen that the actual is 81, that is predicted there is a variance of 2, there is a variance in every quant entities. So now let's check that what our model is fitted on the data set. So first of all we find the intercept, because it's a linear model is work in is y is equals to mx plus c. It is a relationship equations of a linear model linear lines. So we find the intercept that is c and the coefficient. Now we have a plotting our line and our scatter previous plot. So we can say that a model is fitted in this behavior, in which some data is so near and some data is far. So now we have a predict the results on our given input. We have assigning, we have a predict the result on output. Then we can say that the when the student is studying in 9.2 hours, then the predicted score is 92.38 something. So that is our prediction result. So they have some variance in actual design result and predicted result. So we check our evaluate our model performance. The mean absolute error is perfect for uh, finding the relationship, that is the finding for the model performance. So first of all it is by testing and by predicting giving it's a scikit-learn model or matrix uh, feature. So we have a checking that the variance is 3.9 around the 4. So around the 4, the result, if we discuss on our result, the result will be, if there is an error, the result will be 95, it gonna 80 to 88, and it will remain same. So thank you.